I want you to picture a scenario that I think is really becoming the new recurring nightmare for tech professionals right now.
Oh, yeah, I think I know exactly where you're going with this.
Right, so you've been grinding for months.
Yeah.
You finally shipped this incredible new AI agent,
Hmm.
and in the demo,
Hmm.
it is perfect.
Flawless.
Exactly. It's handling these complex queries. It's charming all the stakeholders. It's basically magic. So, you pop the champagne,
And then the invoice arrives a month later.
and that champagne creates a terrible hangover because the bill isn't just high, it is catastrophic.
Hmm.
We're talking about a scenario where the cost of running the software actually exceeds the revenue it brings in.
Yeah, it happens way more often than people want to admit. We are looking at a classic case of the perfect demo disaster bill.
We're actually pulling this from a really sharp piece by Nikhil Mungal. He's the head of AI R&D, and he published this in InfoWorld back on February 27th, 2026.
Right.
And he details this exact situation where a team shipped an agent that worked flawlessly on clean demo data. But once it hit production well, it met the real world.
Messy edge cases, as engineers like to call them.
Yeah.
Because, real world data is never clean.
Right. And this is where I think the fundamental misunderstanding lies for a lot of us. Because if I write a standard script in Python and it hits bad data, it usually just crashes.
It fails out.
Yeah. And it stops costing me money because it stops running. But Mungal makes this crucial point that an AI agent is different.
Yeah.
When an agent gets confused, it doesn't quit. It tries harder.
And that is the danger right there. Trying harder in the world of large language models means it starts looping, it replans, it queries the database again.
Right.
It rewrites its own prompt to try and understand the user.
Yeah.
And to the user, it just looks like the little thinking bubble is spinning for an extra 10 seconds.
Right to the finance team.
To finance, that agent is shovel-feeding cash into a furnace. It is effectively burning money trying to solve a problem it doesn't even understand.
So that's what we're digging into today. We're doing a deep dive into FinOps for agents. Yeah. And I know FinOps sounds like accounting homework, but Mungal argues that in this new world of Agentic SaaS, cost isn't just a line item anymore. It's actually a reliability metric.
Exactly. If you can't govern the spend, you literally cannot afford to keep the product reliable. Our mission today is to figure out how to stop your robot from bankrupting you.
Which is a good mission.
We're going to look at the new unit economics, how to measure success without vanity metrics, and how to architect your system so it doesn't just, eat your gross margins alive.
Let's start with that unit economics piece, because I feel like we have been so spoiled by traditional SaaS. For the last 10 years, if I bought a software seat for a user, I knew exactly what that cost me.
Right, because storage is cheap. Compute is predictable.
Exactly. So why is this so radically different?
Well, because you aren't paying for infrastructure anymore. You are paying for cognition.
Paying for cognition. I mean, that sounds incredibly sci-fi, but also incredibly expensive.
Oh, it is. In the old model, you paid for availability, keeping the servers on. But in Agentic SaaS, you pay for the machine to actually think.
Right.
So every time that agent pauses to reflect, every time it breaks a task down into steps, every time it retrieves a document that burns tokens.
And the more confused it is, the more it thinks.
That's the variable right there. Ambiguity is now a direct financial cost. If a user asks a vague question or the data is messy, the agent has to do more cognitive work to resolve it.
So laziness on the user's part, like just asking a bad question, literally costs the company money.
Direct correlation. A confused agent is an expensive agent. Mungal breaks this down into what he calls the agentic COGS stack.
Cost of goods sold.
Right.
Let's look at the receipt then. Obviously, the big one is model inference. That's the LLM generating the text.
Yeah, that's the raw brain power, but that is really just the top line. The hidden costs are in the tools and side effects.
Side effects. That sounds like a pharmaceutical warning.
It kind of is.
Yeah.
Because agents don't just talk. They do things. They call tools. If your agent decides it needs to search the web, it might use a paid search API.
And that costs money per search.
Exactly.
Right.
Or maybe it triggers an automation that charges a per record fee.
I can see where this goes wrong really fast. If the agent gets stuck in a loop and decides to search the web 20 times to, I don't know, double check its answer.
You just paid for 20 API calls for one question. Mungal calls these tool storms.
Tool storms. That is a terrifying visual for anyone holding the budget.
It gets worse.
Oh, great.
There's orchestration costs, workers, queues, state storage. There's memory and retrieval vector storage, index refreshing,
Right, keeping the data fresh.
and governance,
Right.
tracing, safety filters. But there is another layer in the stack that I think gets overlooked entirely, and it's actually the most expensive one.
What is?
Humans in the loop.
Ah, yes.
This is the ultimate margin killer. If the agent hallucinates or gets stuck or gives a bad answer, who has to fix it?
A support ticket gets opened.
And a human has to answer it. And humans are vastly more expensive than GPU time. Mungle argues that you have to include the cost of that review time and that support load in the actual cost of the agent.
Because if the AI is creating work for humans, it's not an asset. It's a liability.
Precisely.
There was this comparison in the source material that really drove this home for me. Mungle looked at two customers with the exact same license, same software, same price. But customer A cost the vendor 10 times more to service than customer B.
10 times! Let that sink in.
How is that even possible? Do they just use it 10 times as much?
No, the usage volume was comparable. The difference was entirely about workflow standardization.
Okay, what does that mean in practice?
The cheap customer had clean, standardized workflows. The agent knew what to do. The expensive customer lived in what Mungle calls exception land.
Exception land.
Their internal processes were messy. The data was inconsistent. So the agent was constantly fighting through ambiguity, retrying things, failing, and eventually escalating to human support.
That is a huge realization for any software vendor. Your customer's internal disorganization is now a direct tax on your revenue.
It completely changes the sales dynamic. You start having to ask, can we even afford to have this company as a customer?
So if the costs are this volatile, how do we actually measure if we're doing a good job? Because traditional metrics like token count seem pretty useless here. Customers don't buy tokens.
No, they don't. And Mungle is very firm on this. Teams obsess over token counts, but that's like a mechanic counting how many times he turned a wrench. The customer just wants the car to run.
They buy progress. Cases resolved, reports produced. So what's the better metric?
He introduces CAPO,
Yes.
CAPO, cost per accepted outcome.
Okay, let's unpack that. Accepted seems to be the operative word there.
It is. Most teams track cost per run. But if a run produces a hallucination, that wasn't value. That was waste. CAPO forces you to only count the denominator, the bottom of the fraction, if the outcome was actually accepted.
Meaning the user clicked apply or copied the code or, and I really like this one, didn't reopen the support ticket within 7 days.
Exactly. It has to pass a definitive quality gate.
But wait, if I'm only counting the successes in the denominator, what happens to the cost of the failures?
They go right into the numerator. You take your total spend, all the successful runs, plus the failed runs, the abandoned ones, the timeouts, the retries, and you divide that giant pile of money by only the successful outcomes.
Ouch. So the successful runs have to subsidize all the failures.
That is the brutal math of CAPO. If your agent fails 50% of the time, your true cost per outcome effectively doubles.
Wow.
It forces you to realize that reliability isn't just a nice-to-have feature. Poor reliability is a massive financial leak.
This really helps explain why Mungle warns against looking at averages. He says if you look at the average cost per run, you're just deluding yourself.
Because averages hide the crimes. You need to look at the P95 and P99 metrics.
The outliers.
The horror stories. The average run might cost 50 cents, but that one run where the agent got confused, spiraled into a loop, and queried the database 400 times, that might have cost $50. And if you ignore that outlier, you miss the fact that your architecture allows for a $50 mistake.
And if you have enough of those $50 mistakes, you just don't have a business model anymore. You're tracking what percentage of the budget is wasted on failures.
Exactly. You have to design the system to prevent the outlier, not just optimize the average.
So let's talk about prevention. How do we put a leash on this thing?
Mm-hmm.
The source outlines 5 guardrails. And these feel less like friendly suggestions and more like, do this or you will go broke.
Think of them as a budget contract. You are giving the agent a corporate credit card, but you have to set a very strict limit on it at the gateway.
Guardrail number 1, loop and step limits.
This is fundamental. You cap the number of thinking cycles. If the agent hasn't figured out the answer after, say, 5 steps of planning and reflection,
It's probably not going to figure it out in 10.
correct. Cut your losses. Stop the agent, escalate to a human, or ask the user a clarifying question. Just don't let it spin forever, hoping for a miracle.
Guardrail number 2, tool call cap.
This targets those tool storms we mentioned earlier. You set a hard limit. You can search the web 3 times. That is it.
Keep it grounded.
Right. It prevents the agent from burning through your API budget just because it's feeling indecisive.
Guardrail number 3 is a token budget, which makes sense. A strict ceiling on tokens per run, but Mungle adds a specific technical tip here about history.
Yes, and this is just good hygiene. Usually, when you chat with an AI, the system sends the entire conversation history back to the model with every new question so it remembers the context.
Right.
But if you've been chatting for an hour, that history is massive.
And you're paying to process it every single time you hit enter?
Exactly. Mungle says, summarize it. Don't pay to reread the whole novel every time you turn a page. Compress the history.
That's smart. Guardrail 4, wall clock timeout.
This is about user experience as much as cost. If an interactive flow takes more than 60 seconds, the user is gone. They've already tabbed away, so why keep the GPU running? Time it out. If it's a big job, move it to a background job and just email them the result later. Keep the interactive flows fast.
And finally, Guardrail 5, tenant budgets.
This is blast radius protection. If one specific customer, one tenant has a haywire workflow, or maybe a malicious user is trying to crash your system, you don't want them to drain the bank account for the whole company.
Right.
So you cap the spending per tenant using anomaly detection to spot the spikes.
It really is like preventing a runaway robot scenario. You don't want a situation where an agent spends $100 in compute trying to answer a 5-cent question.
That is the ultimate FinOps nightmare. The value of the answer must exceed the cost of finding it.
But here's where it gets really interesting to me. FinOps isn't just about accounting. It's not just about setting limits and slapping the agent on the wrist when it spends too much. Mungle argues that the architecture itself is a financial decision.
Yes. This is the biggest lever you have. It's about how you build the brain.
He talks about splitting the agent into 2 parts, a planner and an executor.
This is a brilliant way to save money. Right now, a lot of developers use one giant expensive model like GPT-4 or the top-tier Claude to do everything. To plan the task, to write the code, to format the output.
It's like using a Ferrari to go to the grocery store.
Or hiring a PhD to update a spreadsheet. It's overkill. Mungle suggests using the expensive PhD model only as the planner. It looks at the user's request, understands the nuance, and writes a step-by-step plan.
And
then it hands that plan to the executor. And the executor can be a much smaller, faster, cheaper model.
Model routing.
Exactly. Rework to the smallest capable model. Use structured outputs. The executor doesn't need to be a genius. It just needs to follow instructions and call the tools.
So you separate the thinking from the doing.
Precisely. The doing usually involves a lot of back and forth with tools, which burns tokens. If you do that with a cheap model, you save a fortune. You reduce those expensive thinking while acting loops.
He also mentions a concept called idempotency. Now, I know that's the $10 word that engineers love, but why does a finance person care about it?
Because it makes retries safe and cheap. Idempotency basically means if I do the same thing twice, the result is the same as if I did it once.
Okay, give me an example of how that saves money.
Imagine your agent tries to write a record to a database, but the connection glitches. The agent doesn't know if it worked, so it tries again. If your system isn't idempotent, you now have duplicate records.
And you have to pay a human agent to go back and clean it up.
Exactly. But if you build for idempotency, the system sees the second request and says, oh, I already did this, we're good. It prevents errors from compounding into more work. It creates a safety net for the agent so it doesn't spiral.
So we've engineered a cheaper, safer agent, but we still have to sell it to customers. And this is where the rubber meets the road. How do we price this? Because if I sell a flat monthly subscription, all you can eat AI and a power user shows up.
You go out of business immediately. Mungle calls this the premium lane concept. You have to evolve your pricing to match your risk.
Most companies start with seat bundled pricing, right? Like agents included.
Yeah, AI included in your license. That works for initial adoption, but it's incredibly dangerous for margins if heavy users destroy them.
Then they usually move to credits.
Buy X credits. Vendors love this because it protects their downside. But customers hate it.
Because they have no idea what a credit is.
Right. Is this research report going to cost me 5 credits or 50? It creates bill shock anxiety. Customers literally stop using the tool because they're afraid of wasting unpredictable credits.
So where is the industry actually heading on this maturity curve?
Towards workflow metering and eventually outcome-linked pricing. This aligns perfectly with that CAPO metric we talked about. You don't pay for the run.
You pay per specific job, pay per case resolved.
Exactly. Pay when the value is delivered. And Mungle predicts the final stage of maturity is value-based contracts.
That sounds intense. Guaranteed business results.
Yeah, it's saying, we guarantee this agent will save you $1 million in support costs, and we take a percentage of that savings.
That puts a massive amount of risk on the vendor. But wait, speaking of risk, there's a trap here with sales demos, isn't there?
Oh, the demo trap. Yes. You have to ensure your sales demos use the paid tier configuration. If you show off the expensive, brilliant model in the demo, but the customer's budget only allows for the cheap model in production.
You're setting wildly misleading performance expectations.
Exactly. Don't promise the Ferrari if they're buying the bicycle. Reserve the smartest models for the premium lane, for high-stakes tasks, or when the cheap model fails validation.
Okay, so before we wrap up, let's get really practical for our listeners. Mungle lays out a 30, 60, 90-day plan for teams that need to get this unit economics problem under control. If you're looking at your cloud bill right now and panicking, what do you do tomorrow?
Days 0 to 30. Stop flying blind. Pick your top 3 to 5 workflows. Define exactly what accepted means for them. Is it a thumbs up? Is it a closed ticket? And start logging every single run.
So you can calculate that CAPO metric to establish a baseline.
Exactly. Get the data.
Okay, days 31 to 60.
Optimization. This is where you implement the architecture changes. Split your agent into planner and executor. Add routing to smaller models. Harden your tools with timeouts and idempancy. And for heaven's sake, implement caching. If the agent answers the same question twice, don't pay the model twice.
Good advice. And the final stretch, days 61 to 90.
Alignment. Set up those anomaly alerts. You want a text message if a tenant spikes their usage, not a surprise at the end of the month. And align your pricing with your entitlements. If you have power users, make sure they are on a metered plan or higher tier so they aren't destroying your margins.
It takes a very scary financial black hole and turns it into a manageable engineering roadmap.
That's the goal. It turns panic into process.
You know, it's fascinating to think that FinOps, which sounds like the driest topic imaginable, is actually determining the architecture of the next generation of software.
It really is.
But there's a bigger picture here, too. Based on everything Mungle laid out, especially around paying for outcomes instead of runs, I think we are looking at a fundamental shift in how the software industry works.
Absolutely. Think about it. For 50 years, we have bought software licenses. And if the software was buggy or hard to use or didn't really solve the problem...
That was the user's problem. Caveat emptor. The vendor already got paid.
Exactly. But we are moving to a world where we don't pay for the tool. We pay for the result the tool creates. If the agent does the work, but the outcome isn't accepted, the vendor pays the cost of that compute, not the user.
That completely flips the script.
It fundamentally changes the incentives for software quality. You literally cannot afford to ship bad code if you are footing the bill for the machine to sit there and spin its wheels trying to fix it.
The wallet becomes the ultimate quality assurance mechanism. If your code is inefficient, your company dies. That is a wild thought to leave you with today.
It's the constraint that breeds discipline.
Well, there you have it. Keep your loops limited, keep your outcomes accepted, and please don't let your robot spend $100 trying to answer a 5-cent question.
And watch out for those tool storms.
Indeed. Thanks for joining us for this deep dive. We'll catch you on the next one.